All right, so the goal for today is to be able to identify functions and the domain and range of functions at 80% accuracy or higher. So this is stuff that we've covered before, just making sure that we are all on the same page. So can you determine if something is a function? Can you determine if something is a function? Can you determine or can you identify the domain as all of the x values in a function? Can you determine the range as all of the y values? Now that seems simple enough, but there's like other forms that you have to be able to read that information as well. So we're gonna go over that today. Otherwise, I think like on the topic 3 tests, those topics you guys seem to do good on. So we're just kind of making sure we're solid in those today because you'll see them more frequently on the test this Friday compared to when we took the topic 3 test. When we took the topic 3 test, it was like 2 questions. On Friday's test, it's like 8 questions. So just making sure we have that solid foundation. I'm recording right now, so feel free to watch it later if you need extra help or if you're like testy, missed the lesson. I also have tons of other videos that I've compiled over the years because we teach this every year. And the videos are like super specific too. It tells you what that video is about. So if you're confused on like a certain part, you can check that out. It's in the slides that are in Schoology. The practice says evens or odds on it. So that means do the evens or the odds. Then when I check it on Friday while you're testing, if you don't get the whole points, upload it to the link in Schoology. I do have the answer key provided on the back cabinet over there. So I expect everyone to like periodically check to make sure that they're doing it right. There have been times that I have like collected the practice as a test, like maybe that class was driving me nuts. And so I was like, okay guys, it's a test now. Turn it in when you're done. And then I grade it for accuracy. And there's kids that go like above and beyond. They do both the evens and the odds, but they do them all wrong. And I feel so bad for those students, but you need to be checking the keys. That's why I have it. So that you can check yourself to make sure you're practicing it the right way. So just an FYI. So we do have a test this Friday. We don't have school tomorrow. So try not to miss Friday. I know sometimes you guys don't have control over that, but advocate for yourselves. Tell your parents, I actually have some important stuff to do Friday, so maybe don't make me stay home. The test, you don't get to use notes, but you can use a note card if you wish. And the test does have a lot of potential to increase your grade because it's over topic 2 stuff and topic 3 stuff. So if you do better on those sections than you did on the topic 2 test or the topic 3 test, when we took those like a month ago, then I will match those scores. I did that for the topic 1 test too. So, you know, take it seriously. It's not just a little quiz, right? It has a lot of potential to increase your grade. So if you need an index card, because you don't want to go to the store and buy a whole pack just to use one, then raise your hand and keep it up until I give it to you. Keyword is keep it up until I give it to you. Anyone else need one? Last call. All right, so you can write whatever you want on here. Otherwise, you cannot use notes, just a note card. And that's Friday. Also Friday, I'll be checking your binders for these note pages. I listed them all out for you. It's 13 total. And it's just over the reteaching unit. So this week, last week, and the week before. That's supposed to be a good grade in the grade book. It's supposed to kind of fluff it up. I know 80% is a big chunk of your grade to dedicate to assessments. That's why we give you binder checks to put in that category to kind of make it a little bit better. So make sure you have it Friday. And if you're not going to be here, make sure that you at some point show me your binder. Any questions? All right, so then let's look at this paper first, the one about domain and range of continuous graphs. So on the topic 3 test, there was not a lot of people that missed the question on domain and range. So you guys seem to have a good understanding that domain is all of the what? Domain is all of the x values, and range is all of the y values. What's a good way to remember that? Dr. XY. Good. So you guys seem to understand that. Domain is all the x's, range is all the y's. We didn't do a whole lot, though, with what are called continuous graphs. So those are graphs that are basically lines versus dots. So for continuous graphs, you will usually have to represent those domain and ranges as inequalities. So we're going to review that. For the domain, since it's your x values, you're going to scan your pencil left to right along the x-axis. Again, domain is all your x's, so scan your pencil from left to right. For the range, you're going to scan your pencil from top to bottom along the y-axis. The y-axis goes up and down, right? And range is all your y's. And what you're looking for when you're scanning for these are any like boundaries where the graph will never go beyond a certain point. That's what we're going to look at next. So like in example 1, we'll start with the domain. So scan your pencil left to right. Going to the left, does it go on infinitely, the graph? Like what do these little arrows mean? That it goes on forever. So it goes on infinitely to the left and infinitely to the right. Notice that it gets wider as we go to the left and right. So eventually it will touch all of the x values. And if that happens, then the domain is all real numbers. All right, you can also see it written as like an R with an extra line in it. All right, all real numbers. As it gets wider as you go from left to right, so it will touch all of them eventually. Now for the range, we're scanning from top to bottom. Now, does the graph go infinitely upward? Yes. Yes. Does it go infinitely downward? Yes. No. It stops where?
-2.
Right there at y equals -2. So when that happens, so it has one boundary, we're going to represent it as an inequality. And where does it stop on the y-axis? -2. So I'm going to leave space for the symbol. I use the letter y because range is all of your y's. Now, would you say that the y values that would be on this line, are they greater or less than -2?
Greater.
Anyone else want to add? Right, I agree, they are greater. Like if I pick and choose, like here y is 0, here y is 1, here y is 2. Those are all greater than -2, right? Does it touch the -2? So then it's also equal to. Does that make sense? Any questions? All right, so if it has at least one boundary, we represent it as an inequality. If it doesn't have boundaries, then it's all real numbers. Now look at number 2. Scan from left to right on the x-axis. Is there boundaries going from left to right? Yes, I actually have 2 boundaries. Since I have 2 boundaries, that means I need to make this a compound inequality. So I need to have 2 of these symbols. Since it's the domain, what letter should we use? X, good. And what's like the lowest x value on this graph? -3, good. Right here, x value is -3. And what about over here? What's the highest x value? The +3. And then I never bother memorizing the symbols. If you want to, kind of just make sure that they're in this format, less than or equal to, when it's a compound inequality. But I just kind of look at it and determine, okay, like, are these x values on this line bigger than -3? Are they smaller? And then I make sure the opening faces the right way. So like here, the x value is 0. Here, the x value is 1. Those are all greater than -3. And then at the same time, those are smaller than the 3. Does that make sense? All right, we'll keep practicing it just in case it doesn't. But that's our thought process. You guys take like 30 seconds and try doing the range part yourself. All right, but what letter should you use for the range? Y, because it's your y value. Like 30 seconds. All right, so sorry, what was the lowest y value? And the highest y value? +3. All right, it just happens to be the same as on the x's, so you can verify it yourself. That y value is 3. This y value is -3. What's the symbol between -3 and y? Anyone get something different? All right, I would agree. The y values that are on that line are greater than -3, right? Like here would be -2, -1, 0. Good. What about between the y and the 3? Less than or equal to. All right, because again, numbers like 0, 1, 2 are all smaller than 0. Questions? All right, so then let's keep going. Some of them we'll do together, some of them I'll have you try on your own. So number 3, scan from left to right for your domain. Does it go infinitely to the left? Does it go infinitely to the right? So my domain is all real numbers. All right, whenever you see those arrows, just pay attention to them. If it keeps getting like wider as you go, then it's going to eventually touch all the x's. What about the range? So scan from top to bottom. Does it go infinitely upward? Infinitely downward? So my range is good. So number 4, for the domain, scan from left to right. Are there any boundaries from left to right? So look at your arrows. So it goes infinitely downward, we know that for sure, but does it get wider as we go down? So eventually it will touch all the x values. All right, so that one's actually all real numbers. because it gets wider as you go down. So we'll eventually touch them. The range, are there any boundaries on the range? So scanning top to bottom. Where is the boundary at? 4. Good, right here. So where y is 4. So since it's also, just side note, does it go infinitely downward? So there's only one boundary. So that means I should only have one inequality symbol. So y compared to 4, are the y values that are on this line bigger or smaller than 4? Does it touch the 4? So less than or equal to. And if you're confused about the less than part, all right, just pick some points off of this line. All right, here the y value would be 3. Here the y value would be 2. Those are smaller than 4. That makes sense? All right, I'm going to have you guys try number 5 from start to finish. So identify the domain and range of number 5. You should have noticed that when you scan from left to right, that there are 2 boundaries. All right, it does not go infinitely to the left or infinitely to the right. It stops at x equals -1 and 5. Right, so it should be a compound inequality. You could memorize the symbols as less than or equal to, or you can just think about it logically. All right, the numbers that are on that line for the x's are all between -1 and 5. All right, and then for the range, the highest y value is 3. Lowest y value is -3. So 2 boundaries again has to have 2 inequalities. Questions about that? All right, and then let's look at some of these other ones, some of the solutions. Let's make sure they make sense. All right, do you guys see how it goes infinitely from left to right on number 6? Right, it does get wider. So that means it will touch all the x values. That's why the domain is all real numbers. All right, for the range, does it go infinitely upward? Yeah. Does it go infinitely downward? Yeah. So again, all real numbers. That makes sense. All right, let's keep going. On this page, pretty much out of these 4, I mostly see ones that look like number 8. On your guys' test. All right, but these other solutions are kind of cool to see too. They do make sense. So like in number 7, it does go infinitely left to right. But if you look at the graph, the highest point on the y is 2, lowest is -3. Number 8, there's only one boundary on the x-axis. And that's at where x is -1. See? That is only one inequality. And then it does get wider as you go to the right, so it will eventually touch all the y's. All right, any questions? All right, so there's quite a few of those on your test, so be able to pick the correct of the options. Look for your boundaries. Every boundary should be an inequality. All right. Now let's look at the functions page. All right, so this one. You guys also seem to be good at functions too, so we're just kind of dusting off the cobwebs. All right, the formal definition for a function is when every x value has exactly one y value. All right, that's the formal definition, where every x has only one y. One that I think is easier to remember is just that there are no repeating x's. Because if you see that the x's don't repeat, it's automatically a function. And with these, there's a ton of ways that the information can be displayed to you. It can be ordered pairs, it can be a graph, it can be a map, it can be a table. So just making sure we can look at all our x's and see if any of them repeat. So if the x values repeat, it's not a function. So here's an example. If I have 3, 2, and 3, 3. So I have the same x value with 2 different y values. Is that allowed to happen? So it's not a function. There cannot be repeating x's. Now, if I have repeating y's, like 3, 1, and 4, 1, is that allowed? Yes, the definition doesn't say anything about y's not being able to repeat. So this over here is a function. All right, we don't care if the y's repeat, we just care about if the x's repeat. Does that make sense? And then also, if you have graphs, it just tells you you can use something called the vertical line test, where if a vertical line intersects a graph more than once, then it's not a function. You'll see that more towards the end of your note sheet. All right, now without saying it out loud, let's look at number 1. So don't say it out loud. Just look at it. Is number 1 a function? Just think about it. All right, is it a function? Yes or no? You can say it now.
Yes.
All right, good. And why? Good. All of the x's are different. None of them repeat. So no repeating x's. Then yes, it's a function. Now look at number 2. Don't say it. Just look at it. Is number 2 a function? You can say it now.
No.
Good. What is wrong with it?
There's 2 positive.
Good. We have some x's that do repeat. And when you look at their y's, are they different?
Yes.
Good. So that means that it's not a function if their y's are different for the same x. So no, it's not a function. A good test question would be, how can I make this a function? Like what coordinate can I replace? And then, so you could see that on your test. All right, number 3, don't say it yet. Look at it. Is number 3 a function?
No.
Which one repeats?
-3.
Good. So -3, and again, it has 2 different y's. So no, it's not a function. Number 4, don't say it yet. Is number 4 a function?
Yes.
Yes. All right, so all of the y, or not y values, all of the x values are different, so we don't even need to look at the y's. You automatically know it's a function. Questions? All right, and then I know we didn't cover it today, but you guys all seem to know it before. If I ask you for the domain and range, domain is all the and range is all the y's. All right. Number 5. Look at it. Don't say it yet. Is it a function?
No.
Which one repeats?
3.
Good. So just pay attention to those details. It's represented a different way this time, but you can still see all the x's clearly, right? So it's definitely not a function. Number 6, is it a function?
Yes.
Yes, there are no repeating x's, right? So it is a function. Look at number 5, don't say it yet. or sorry, not number 5, number 7. Is number 7 a function? Yes or no?
Yes.
Good. All right, is number 8 a function? What repeats?
4.
Good. No repeating x's, or at least they should not have different y values. Good. Now we have some maps here. The maps will never list a repeating number. If anything, they will just have another arrow pointing if it does repeat. So like look at number 9. Is that one a function?
Yes.
Yes, because each x has only one y. So it still goes in the order x, y. So yes, this one's a function. Is number 10 a function?
Yes.
It is not a function. Which one repeats? Good. So you see on -1 has 2 arrows coming from it. So that means it has 2 different y values. That's not allowed. All right, so that one is not a function. So it doesn't list it more than once. It just has the arrows. You have to look at those. All right, backside. Now we're getting to the vertical line test to determine if it's a function or not. But before we get into that, I did see on your test for this Friday stuff that looks like 11, 12, or 13, and they asked for like the domain and range. Would you guys be able to handle that? Yeah? Can you list all the coordinates that are here? Yeah, so like what's this coordinate over here? Good, and then this one would be good, and you would do that for all of them. And then the domain is all the
X.
and the range is all your one. Yes. So just making sure you guys know how to do that, because you will see it Friday. But the question being asked right now is it a function or not? And we're going to use the vertical line test. So you draw vertical lines basically through each data point. If it hits more than once on a vertical line, then it fails. And if it fails, is it a function? So number 11 is not a function. It fails right here. There's 2 dots on one vertical line. So that means that x has 2 different lines. Would number 12 pass the vertical line test?
Yes.
So is it a function?
Yes.
Yes, good. So I can draw vertical lines. Never hits twice. Number 13, is it a function?
No.
Where does it fail? At x equals 3. It has 2 different y values. Can't even see the other dot. All right. That's not okay. It's not a function. All right. 14 through 16. Use your vertical line test. So draw your vertical lines. Oops, that's not vertical. All right, pretend that they're perfectly straight lines. Does it ever hit at more than one spot on the line?
Yes.
Yes, like here and here. Or here and here. It just has to fail once for it to not be a function. So 14 is not a function. Would 15 be a function? Yes, it would pass the vertical line test. Would 16 be a function? Yes, this one would pass the vertical line test. Questions, comments? All right, I'll let you practice here in a little bit. There's one thing that I forgot to go over with you guys, so let's just go over it now. So also with functions was function notation. So just remember, function notation is that f of x stuff. So if I see things like in number 1, f of x equals x plus 7, and then it says find f of 5, what am I doing with that 5? What does the 5 replace? X, because normally it's f of x, now it's f of 5. So if you see things like that on your test Friday, which you will, all you're doing is plugging in that number. So I have f of 5 equals, normally it's x plus 7, now it's 5 plus 7. Remember, the left side is just notation. It's not f times 5. It's just saying that 5 is my input. On the right side is my output once I simplify it. So what's 5 plus 7? 12. All right, function notation shows you the input and the output. So be able to do that, be able to solve it, to plug it in and solve, and then to interpret it. So if this was like how many tickets were sold and how much money was made, then you should be able to tell me 5 tickets were sold and we made $12. Right? So be able to interpret it. Questions about that? All right, over here in number 2, it's a little bit longer. If I needed to find g of 1, what am I doing with that 1? Substituting it in for the x. So I have g of 1 equals 3, normally times x, but now it's times 1, minus 8. Again, the left is just notation, just leave it alone. On the right, simplify it. It's 3 times 1, 3 minus 8. Input and output. Questions? All right, so just making sure we understand. So that gives you a lot of time